Lesson 3.4, Pythagorean Theorem and Trig ratios. We should know the Pythagorean Theorem says a squared plus b squared equals c squared. Or in other words, a and b come from the legs, and then c is always the hypotenuse. So in this first example, the legs are the two sides of the triangle that form to meet the 90, the right angle. So this would be my other leg. To plug it in, 2 can go in for either a or b, so I'll say 2 squared plus, I'll call it x squared, would equal the hypotenuse of 4 squared. 4 squared is 16, 2 squared is 4. I would subtract the 4 from 16, and that's 12. And then to make x not be squared, I would square root both sides. And remember that you need to reduce radicals if you can. So those perfect squares we've talked about, this one would have a perfect square of 4, and then be times a non-perfect square of 3, right? 4 times 3 makes 12. Well, the square root of 4 is just a normal 2, so this would be 2 square roots of 3. Next example gives us both legs. We're finding the hypotenuse or the c, so go ahead and try that one. I didn't do a very good job of organizing my work, but I got down to x squared equals 128, and I brought it up here. 128 has a perfect square of 64 in it. Square root of 64 would be 8, and then times the radical 2 that's left over. So these problems on Delta Math, you'll have to find one of the sides, I believe. But here I wanted to go ahead and speed that up. Maybe not. Maybe I'm wrong on that. But we've got our SOHCAHTOA, our sine, cosine, and tangent. Those are the 3 basic ones, and then we have the 3 reciprocal ones we'll get to here in a minute. Sine, or SO, stands for its sine is the ratio of the opposite leg over the hypotenuse of the triangle. And remember that they're going to say like sine of A, that's your angle you're looking from. So I'm going to be looking from here, right? And they use this little Greek symbol called theta. It's a circle with a line through it. So if this is the angle I'm looking from, I need the opposite side to that angle, and it's where that angle opens up into. So 6 would be my opposite. My hypotenuse is across from the 90, so that'd be the square root of 45. But we have some work to do to simplify this answer because I cannot have a radical in the denominator. So I would multiply by square root of 45 over square root of 45. That becomes 6 square roots of 45. This is really 45 getting squared and then square rooting it, which just makes it back to 45. The problem here is 45 can also be simplified. That has a perfect square of 9 in it. It'd be 9 times 5. Square root of 9 is a 3. So this 3 will have to get multiplied by this 6. So that's becoming a 6 times 3 with a square root of 5 left over. 6 times 3 is 18 square roots of 5 over 45. And then 18 45ths needs to get reduced. 18 and 45 can both be divided by 9. So that would be 2 fifths. So your final answer is 2 square roots of 5 over 5. On the next one, I'll show you a different way you could do it, and maybe that will take up less work. Part 2 is finding cosine of angle A. So again, we would be looking from this angle right here. We need the adjacent over the hypotenuse. Adjacent would be the leg that is touching the angle. That's not the hypotenuse, so that would be this one. It would be 5 over, we don't have to use radical, 5 over 10. And that reduces to a half. So that one's really easy. Number 3 is tangent. TOA is the opposite leg over the adjacent leg. We're still going from angle A. So this would be our theta. Opposite is the square root of 28. I'm going to go ahead and fix this radical right now. That would be the square root of 4 times square root of 7. That would become a 2 square roots of 7. So I would have 2 square roots of 7 over the adjacent leg, which is 6. It can't be 8. 8's my hypotenuse. 2, 6 reduces down by 2, so that'd be a 1 and a 3. So I get square root of 7 over 3. All right, now the trickier ones. The reciprocal functions. Cosecant is actually the reciprocal of sine. That's what this means when you put 1 over sine, it's just flipping it. So where sine was opposite over hypotenuse, now we're going to have hypotenuse over opposite, and you somehow have to remember that. Okay, we're going from angle J, so that's our theta. Hypotenuse would be the 73 over the opposite 48. I don't think that can reduce. Nope, so I'm going to leave it like that. Okay, secant is the reciprocal of cosine. So where cosine ca was adjacent over hypotenuse, now we have hypotenuse over adjacent. Going from angle T, we would have our hypotenuse being 29 and the adjacent being 20, and that can't reduce. I believe it was these you had to do Pythagorean theorem on. Delta math. And then cotangent of y, well, we switch it up on us. Cotangent from here, it's our theta, is going to be the reciprocal of tangent. So instead of opposite over adjacent, now we have to put adjacent over opposite. So this would be our adjacent side is the 36 over the opposite leg, which is the 77. And that cannot be reduced. And we're done.